Welcome back to chapter 7. This video we're going to cover section 7.2 in our text, which deals with two variable linear systems, meaning equations that are in two variables with exponents 1. Okay, so we're going to go over specifically elimination method, and we're going to go over how to interpret graphically the number of solutions that there are for the system, and then we're going to possibly do some modeling. Okay, so elimination method, what is it? So we've studied two methods: substitution for solving a system of equations, in other words, finding their intersection, right? Substitution and graphing. But now we're going to go through what's called elimination, and we've seen this before, but let's just refresh our memory. So the key step in this method is to obtain coefficients that are the same, but they change sign, okay? So that when you add them together, you eliminate the variable, okay? Or you can think of it as you're subtracting, or however you want to think about it, as long as if you think of it as subtracting, you need to make sure that the negative applies to the entire equation. So it's kind of, I think it's best to just consider it that you're adding, but making sure that your coefficients match, okay? And that one is negative and one's positive. That way it will cancel. Okay, so in that case, we eliminated the x term and we solved, we were able to simplify and solve for y. And then once we have y, we can substitute it back into the original equation to solve for the other variable x. Okay, so what is the method of elimination? So here's the steps. So first of all, you have two linear equations. We need to have coefficients for x or y that are the same. They're exactly the same except one is negative and one's positive. Okay, so we need to figure it out. If it's not like that, we need to multiply whatever we have to do to get them to be the same. Okay, and then once we have them the same, except for one is plus and one is minus, one's negative, one's positive, rather, then we add them together and that eliminates that variable, and then we solve it, and then we substitute back into the original equation, either one, and solve for the other variable, and then we check that it satisfies the equations. Okay, so here we go. Let's do an example. So we have here 3x plus 2y is equal to 4, and 5x minus 2y is equal to 8. So the y's are already same coefficient, different signs. So let's go ahead and just add those two equations together. If we do that, we get 3x plus 5x is equal to 8x. The two y's cancel out, of course. And then 4 plus 8 is 12. So you get 8x is equal to 12, and you solve for x, you get x is equal to 3 halves. And we substitute this back into either equation and then solve for y. So let's take the top one, equation 1. 3x plus 2y is equal to 4. Plugging in 3 halves for x, we get 9 halves plus 2y is equal to 4. And then subtracting both sides by 9 halves, and then multiplying by 1/2 or dividing by 2, you get y is equal to negative 1/4. Okay, so if we plug that into the original system, you would see that it checks. Okay, let's do another one. We have 2x minus 4y is equal to negative 7, and 5x plus y is equal to negative 1. So in order to obtain coefficients that only differ in sign, we're going to multiply the second equation by 4. Okay, so we get the same thing for the equation 1, but then on the bottom we would get 4 times 5 is 20x plus 4y is equal to negative 4, because we multiplied every single thing in that equation by 4. Now when we combine them, we would get 22x is equal to negative 11, and then solving for x, we would get negative 1/2. Okay, and we substitute back into the first equation, we would get 2 times negative 1/2 minus 4y is equal to negative 7. And then we would add 1 to both sides. We get negative 4y is equal to negative 6. And then dividing, we get y is equal to 3 halves. So your solution is negative 1/2, 3 halves. Okay, so then when you plug that in, you'll get the original equation. We're saying, hey, this little question mark means, hey, does the left-hand side match the right-hand side? And it does. And then this one, it does match, so they check out. So let's do another example, because we love examples. Okay, let's solve the system of linear equations. 5x plus 3y is equal to 9, and then 2x minus 4y is equal to 14. Okay, so in this case, it's not very obvious which variable to cancel. So what we're going to do is, since 3y and 4y, one's positive, one's negative, I'm going to multiply the top equation by a 4 to change that coefficient to 12. And then I'm going to multiply the bottom equation by 3 to change that coefficient to 12. And that's what we're going to do. So on the top, we have 20x plus 12y is equal to 36. And for equation 2, we get 6x minus 12y is equal to 42. And then when we add them, the y's cancel out. We get 26x is equal to 78. And then when we divide both sides by 26, we would get that x is equal to 3. Then we substitute back into either equation. So let's put it into equation 2. And we get 2 times 3 minus 4y is equal to 14. So 6 minus 4y equals 14. And subtract both sides by 6. We get negative 4y is equal to 8. And divide by negative 4, we get negative 2. So the solution is 3 comma negative 2. And you can check this on your own time for fun. Okay, so in this example 2, the two systems of linear equations, when you multiply, so you know how we multiplied the bottom equation by 4? They're called equivalent systems because they have the same solution set. So how do we create an equivalent system? Well, we interchange any two equations. We multiply an equation by a constant that's not 0. And we add a multiple of one equation to another equation in the system. Okay, so let's talk about the graphical interpretation of solutions, okay? Now we're talking about, this section deals with lines only, okay? So this applies only to lines. So it's possible for a system of linear equations to have exactly either one solution, 2 or more, or no solution, right? Well, that's kind of in general too. But if you have a system of linear equations, if a system of linear equations has 2 solutions, then it must have an infinite number of solutions, okay? Because the lines in this level of math, where we are, lines do not bend, they're straight. So if you have two points that are the same, then all of the points must be the same, okay? All right, so let's see here. So what, if you have exactly one solution, what does that mean graphically? That means that the 2 lines intersect at one point. What about the slopes of the lines? Well, the slopes of the lines will not be equal, right? Because if they were equal, they'd be parallel, or they would be infinitely many. So if you have infinitely many solutions, that means graphically that the 2 lines coincide. They're on top of each other, or you can think of it as they are identical, okay? If that's the case, the slopes of the 2 lines are equal. And then if you have no solution, that means that you have 2 parallel lines which never touch, right? They never cross, and so the slopes are also equal. Okay, when you have one solution, we say that the system of linear equations is consistent. Okay, a consistent system with one solution is called independent, where a consistent system with infinitely many solutions is dependent. So you have dependent, independent, which are both consistent, and then you have inconsistent when it's no solution. Okay, so let's go ahead and match each system of linear equations with its graph, and let's talk about the number of solutions and state whether it's inconsistent or consistent. So I would either take a picture of this or pause it and then write down your answers, and then we'll go over the solutions, okay? All right, so for A, we have 2x minus 3y is equal to 3, and negative 4x plus 6y is equal to 6. So if I divide the second equation by -2 or -2, I'll get almost exactly the same thing, right? Except the different, 1 is 3, 1 is -3. So this one will be, A is a pair of parallel lines, okay? They have no point of intersection, and they're inconsistent. So B is 2x minus 3y is equal to 3, and then you have x plus 2y is equal to 5. Okay, so this one is going to have 1 point of intersection. Okay, so that's the third one. That's 3. And then C, it's actually exactly the same line. Okay, so C, it looks like A, but it's different. Okay, a little bit different. C is, if you divide everything by -2, you will get the exact same equation. So that's a pair of lines that coincide. It's consistent, but it has infinitely many solutions. So this is basically the same thing that I was saying, but in written form. Okay. All right. So let's do another example. This no solution case. Okay. I think I labeled my last slide wrong. Sorry. That's okay. So this is example 5. The last one was example 4, the solution of example 4. Okay, so let's solve the system of linear equations. We have here x minus 2y is equal to 3, and negative 2x plus 4y is equal to 1. Okay, so let's see if we can use elimination here. So let's take the top equation and multiply it all by 2. So we would get 2x minus 4y is equal to 6. And then when we combine them, we get something weird. We get 0 is equal to 7. Well, is 0 equal to 7? No, not today, or not here at least. So because it isn't, what does this look like graphically? They're basically two parallel lines, okay? So they never touch. That's why 0 equals 7, or rather it doesn't. It's a false statement, and we would say that it has no solution, right? Let's do another one. Let's solve 2x minus y is equal to 1 and 4x minus 2y is equal to 2. So let's go ahead. In this case, let's divide the second equation by -2, or multiply everything by -1/2. So if we did that, we would get -2x plus y equal to -1. And if we combine those together, we would get 0 is equal to 0. Now this begs the question, what if I had decided to multiply the top by -2 and then add them? Well, you get the same thing. You'll get 0 is equal to 0 every time if you're doing the process correctly. And what does that mean? That means that there's infinitely many solutions. These lines coincide. They're exactly on top of each other. So they touch at every single possible point, okay? So that is that. So that's 7.2 for you guys. Your homework is 1 through 41 odd, and that is it for me, and I will see you guys on the next video.